In today's live session, we are going to be discussing electrostatics in physics. Okay, now electrostatics is quite an important aspect of electricity in physics as it forms part of the basics. Okay, so it is important that students have knowledge of electrostatics in physics. Okay, now first things first, what is electrostatics? Electrostatics is simply the study of charges at rest, that is charges that are not moving, charges that are not in motion. Okay, that is what electrostatics talks about. Okay, it is a branch of electricity. We have current electricity, that is for moving charges, and then we have static electricity, which is for what now, stationary charges. So we are analyzing, or we are talking about, okay, or we are working on charges that are not moving, but rather they are what now, stationary or at rest. Now, I'm going to be going through the surface of electrostatics, of which I already have a full video in the playlist if you need the complete section of electrostatics that has been talked about. But this one is quite important. It is a live session, and then we're going to still go over electrostatics. Okay, now we just defined electrostatics as the study of stationary charges, that is charges that are not moving. Okay, now having that in mind, let us first of all start from the basics, which is what now, atoms. Okay, how do we find out charges inside of atom? What is the atom made of, and how does an atom create a charge? Okay, now I'm going to draw a sphere on the board. Okay, now in this circle, in this circular shape, we are having inside of it what we call the nucleus. Okay, now the nucleus of an atom is inside of the atom, and then outside of it we have the shell. Okay, it is in this shell that we're going to find electrons. Okay, so in this shell, this outer shell, okay, we find what we call what now, electrons. I'm going to write here electrons. Now, electrons are designated as E with a what now, superscript of minus, that is E minus on top, to tell us that these guys are having a charge of minus, they are negatively charged. We're going to talk about that later on. Okay, now inside of this electron, inside of this nucleus rather, we have other charges, okay, or other particles. Inside of it, we have what we call the proton. Okay, now the proton in terms of mass is having a higher mass than the electron. Okay, we usually designate it as what now, P with a plus. Okay, that's for the proton. And then inside of this same nucleus, we have what now, a neutron. Okay, now neutrons do not have a charge, they have a net charge of 0. I'm going to explain why. These ones, a net charge of -1, net charge of +1, net charge of 0. We'll see that along the line. Okay, so basically for an atom, we're having a shell outside of it, okay, in which we are going to find electrons. Now inside of it we have nucleus. Inside of the nucleus we have protons and neutrons, of which in summary these three are the basic components of an atom. Okay, now another thing you want to ask yourself is, how does an atom create a charge? Okay, remember, we could have a positive, we could have a negative charge, but how can an atom form a charge? I like making use of two particular atoms. Okay, I like making use of these elements. We have the sodium atom, and then we have the chlorine atom, of which I have picked one from the group 1 elements, okay, which is a metal, and I have picked one from the group 7 elements, which is a non-metal. Okay, now we do know that sodium has an atomic number of 11 and a mass number of 23, right? And then this one has an atomic number of 17, mass number of around 35. Now this small number here is what we call the atomic number. Okay, now the atomic number tells us its position in the periodic table, right? But then that is not what we're going to lay emphasis on, as this is physics, not chemistry. Okay, we're going to lay emphasis on the fact that this atomic number does not just tell us its position in the periodic table. Okay, it also tells us that this sodium atom has 11 protons. Okay, that is 11 positive charges. Okay, as well as 11 electrons, that is 11 negative charges. That is what these numbers are telling us. Okay, so for a neutral atom, okay, for an atom that is not interacting with the electric field or with other atoms, its net charge is what now, 0, right? Because we're having 11 protons and 11 electrons. Let us see how that is actually true. So having 11 plus and 11 minus. Now one proton cancels one electron, one proton cancels one electron. They are 11, so they both cancel each other. Hence the next charge is what now? 0. Okay. Now let us now see what will happen when this guy decides to take part in chemical reaction, or it decides to be interacted with electric field. Okay, so now I want to see how either a positive or a negative charge will be formed, which is still the basic of electrostatics. Now, first of all, talking about the electronic configuration, you can see now that I'm going slightly off physics into chemistry, but they are twisted, so you need one concept from one aspect to explain the other. Okay, let's go a bit deep into electronic configuration of sodium atom. Okay, we already know that in the sodium atom we're having two electrons in the innermost shell. Okay, and then we have another outer shell. We have another one here. Okay, we have 8 in the next one, and then in the last one we have just one. Okay, I would like to put this one in a different color. Okay, we have just one. Okay, now let's count. We have 2 here, we have 8 in the second one, that's 10, plus this one, that's 11. Okay, of which the electronic configuration of this guy is 2, 8, 1. Now what you notice is that if this guy is to take part in chemical reaction or have anything to interact with it, what it wants to do is to give out this electron. Okay, let's use an instance of soldiers going to war. Okay, let's say we are having some soldiers in here, we're having some soldiers in here, we have 2 soldiers here, we have 8 soldiers here, and then we have 1 here. Okay, you see that because this soldier is alone in this shell, it will be easier to kill this soldier, that is remove it, okay, from its army. Okay, so we are going to what now? Remove this guy for sodium to take part in chemical reaction, because it is the easiest to kill this one. So you can just what now? Remove it. It does not have any other soldier with it. Okay, so it's easier for this guy to give it out. Now when it gives it out, remember that all of these guys we're having here, all of these are electrons, all these small circle sections. Okay, they are what now? Electrons. All these balls, let's call them balls, they are what now? Electrons, or soldiers. Okay, they are what? Electrons. Initially they are what now? 11. So once this guy takes part in chemical reaction, is what now? Gives out its outermost what now? Electron, in the sense that after giving this out, we're not going to be left with what now? 10 electrons, right? How about the number of protons? Number of protons remains the same. Okay, in fact, protons do not take part in chemical reactions like this. Okay, they don't take part in bonding in chemical reactions like this. Okay, because they are slightly massive. Okay, they are having a higher mass than electrons. I'll give you a table on the masses of these guys as well. Okay, they're having a higher mass than electrons, so they don't easily move. Okay, electrons are not so massive, so they are the ones that are free to move, causing charges to be created, which could be positive or negative. Okay, so once this guy gives it out, it becomes what now? It now has a total electron of what now? 10. So we have 10 E minus, right? And then we have proton number remaining what now? 11. So we have 11 protons as well. Remember, 11 protons cancels 11 electrons to give us 0. In this case, we're now having 10 and we're having what now? 11. What do we notice? If we choose to cancel each of them, 1 electron cancels 1 proton, 1 electron cancels 1 proton, we're going to be left what now? 0 electron, 1 proton. So it's like subtracting 10 from 11, you get what now? 1. P is greater than E by what now? 1. Which means we're going to be left with 1 proton, and protons are positive charge. That is the reason why we are going to have Na when it is becoming charged, or when it takes part in chemical reaction, we get what now? Na minus 1, or Na minus, or Na plus 1 rather. Okay, we get Na what now? Plus 1, or Na what now? Plus. Okay, hence for a positive charge to be formed, what will happen is that the atom is going to what now? Give out some electrons. Okay, it loses out some electrons, hence we are being left with what now? The positive charge. A very easy concept. Now talking about the chlorine as well. Okay, talking about the chlorine, which is a non-metal. Okay, let us see how this guy is going to behave, or how the negative charge is going to be formed. Similar action is responsible. Okay, now in this case we're having 17 protons which are positive. Okay, and we're having 17 electrons which are negative as well. Let us see the shell and electronic configuration as well. Okay, so we have 2 8s, and then we have 7, right? 2 plus 8, that's 10, plus 7, that's 17. So we have 17 here. Now if you check the shell, we have 2 inside of it. Okay, we have 8 again. So this is 4, 5, 6, 7, 8. And in the outermost shell, we have 1, 2, 3, 4, 5, 6, and then we have 7. Imagine these guys again as soldiers. Now, if these guys are to go to war, okay, what do you think will happen? These soldiers inside are super protected. Even these ones outside, they're super protected. Unlike this one, we'll have just one soldier. Let me represent this one with a single, with a red color. Okay, so it becomes easy to identify. Okay, in this case, we're having just one, so it was easier for this guy to be killed, okay, or given out. Now, in this case, we're having what now? Not just one, but we have 1, 2, 3, 4, 5, 6. So we have in total 7 what now? Soldiers in the outermost shell. So it will not be easy to kill this guy, okay? But rather, because they are 7, okay, they are more in numbers, it will be easy for them to bring another soldier into their own army, okay? So if they do that, they will bring in what now? Another what now? Soldier. And remember, in real sense, these guys are electrons, okay? So the soldier is an electron. So I'm going to say this soldier here is what now? Negatively charged, okay, an electron. So if you bring this guy in, we now have what now? How many in the outermost shell? We now have what now? 7 plus 1. That becomes what now? 8, right? So the total number of electrons or total number of soldiers becomes what now? 18. Notice that we're now going to have a new number of soldiers or electrons, which is what now? 18 electrons, right? Now let us check for the net charge of this guy and see if it balances. We're having 17 protons. We cancel out 17 electrons inside of here. We'll be left with what now? 1 electron. An electron is minus, okay? So I'm going to have what now? Cl minus. So you see, the concept is quite basic. This is the reason why we're having negative charges. This is the reason why we're having what now? Positive charges, due to either a loss or gain of an electron, okay? Now mind you, if this guy was to give us 2 electrons, okay, this would have been plus 2, 3 electrons plus 3. If this guy was to receive 2 electrons minus 2, 3 electrons minus 3, and so on and so forth, okay? The concept is quite basic. Now, there are other things that must be talked about that we should look into, okay, under electrostatics or static electricity, okay? Other important concepts and aspects that should be talked about, okay? Of which we are first going to discuss the principles, okay? I'm going to talk about the principles of electrostatics, okay? Now, the first principle I'm going to talk about is the principle, okay, of charge quantization, okay? We have basically 2 principles. We have principle of charge quantization, okay? And then we have principle, okay? We also have the principle of charge, okay? We have 2 basically. We have the principle of charge quantization, and this one, I would like you guys to think about it, okay? You can pause the video and guess what this one is going to be. So we have principle of charge quantization. I'll assume by now you guys have paused the video and thought about it, okay? And the next one is principle of what? Charge conservation. I expect you should know that one. That is why I gave you the first one, quantization. Now, conservation is easy because before now you should have heard about energy, what now? Conservation, okay? Here we said energy can either be created or destroyed, okay? So it is similar to this one. We have charge quantization and what now? Charge conservation. Conservation is very easy to remember from what now? Energy. So this one is called what now? Charge conservation, okay? So we have charge conservation. Now, what are these 2 guys? What do they talk about? What do they talk about, and what do we use them for? Okay, they are very, very important. Now, in terms of charge quantization, what do we use it to do? Okay, first of all, what is the principle behind charge quantization? Now, charge quantization, okay, is simply saying that we can actually count the number of charges in a system. Okay, for example, charge is measured in coulombs. Okay, let's say the total number of charge we got from a body was 50 coulombs. Okay, to get the number of charges inside there, we are going to divide by the amount or the charge of an electron. Okay, you might still not understand. Let me now rephrase it. Okay, charge quantization simply states that, okay, the total charge in a body is equal to the multiple of the charge of an electron. Okay, that is, we are going to say that charge quantization, okay, charge quantization is telling us that the total charge, okay, of a body is equal to what now? Multiple of the charge of an electron. Now take note, I'm going to put a plus here simply because when we count, it's always positive. There's no way we're going to count the number of items in the container. We'll get what now? Minus 60. It doesn't make any sense. Okay, now in actual sense, when you're counting, it should be what now? Positive. Okay, so this is what now? The formula that is derived from the principle of charge quantization, where n is called the charge quantum number. That is the number of charges that is present in the body. Okay, and Q is the total number of charge, E is the charge of an electron, which I'm still going to give you in the table. Okay, now how about charge conservation? Okay, how about charge conservation? Remember, for energy, we said energy can neither be created nor destroyed. In this case, that's not what we're talking about. Okay, but in this case, we are going to say that charge conservation is talking about that the fact that when we have a closed system, okay, when we have a closed system,